Okay, so let us just start our conversation with understanding polygons. Polygons are just the figures, basically closed figure. There are three criteria in which if a closed figure follows, we would be calling that figure to be polygon. Number one, it is made up of straight lines. Straight lines must be present everywhere and must be closed. And another property which a polygon should have, the edges must not intersect. So these are my three conditions to name any figure to be a polygon. So let us quickly see few of my figures which I will be calling them to be polygon. Like I have a shape of a triangle, this is my polygon. Likewise I also have shape of my rectangle, or I can also have a polygon like my, if I just draw a star type structure, you may just ignore that blend. Let me just draw it carefully. Okay, so yeah, since all the lines are straight lines, this is also a closed figure wherein the edges are not intersecting, so I would categorize all this figure to be polygons, or valid polygons. And there are few of the images, not the few, but the major section in our mathematical dimension where the figures may not be a polygon, like a figure being like this, where the polynomial is not complete or it is closed, and another figure which would be like this, which is closed but the edges are intersecting with each other, and another being like this, so where we would have a simple little bit of curve. Likewise, if we also have a polygon shaped this, so it is now also a polygon since one of the edge is not a straight line. So I would categorize all the sort of my figures to be a non-polygon. Okay, figures that are non-polygons. So these are my basic classification of what are polygons. Let me just quickly summarize. It must be straight line, it must form a closed figure, and edges must not intersect. So let us now quickly see about the little bit of polygons, standard polygons we have. See, a closed polygon would be formed at least with my three of the edges. I cannot draw a polygon with a single straight line or with two itself for being it closed. For making it closed, I must have at least three of my edges, straight lines. So when the three edges intersect to form a polygon, I would be naming it as a general triangle. Seems clear, as you have already understood in your previous classes. Clear till now? Any issues? I am here to address those issues. You may just ask without any hesitate if you have. So let me draw another polygon, four-sided polygon. I would be naming it as quadrilateral. Okay, these are basically the name convention you would be remembering for your tests and exams. These are just random, not the random, these are just generalization of my polygons, which is my three-sided, this is being three-side, this is being four-side. Similarly, I have a five-sided polygon named as, since 5 it is pentagon, it is a general pentagon, I would be naming. For six-sided, I would be having a hexagon, 2, 3, 4, and further 5 and 6, so it is my hexagon. Similarly, you can go till n-gon. N-gon means nth polygon. Nth polygon you may extend up to. Like I would like to assign a question for drawing a 9-sided polygon. Can you just pause, or can you just try at your own, and you may just pinpoint if you have drawn it. So you please please go ahead and draw it. Okay, I think so you might have drawn, wherein you would be encountering connection of 9 of the edges, which is 5, 7, 8, and this is 9. So something like this, I would be having a polygon, 9-sided polygon, which you might have drawn. Yeah, you have drawn. Yeah, you may just see my polygons can vary in shape, but it should have the required number of sides, which is with the straight line, and it must form a closed loop without intersecting my edges. So it is my 9-sided polygon. Similarly, let us now classify polygons into two types, one being my convex polygons, one being my and another being my concave polygon. So let us discuss about concave first, after which we would be considering convex. So I have if a polygon satisfy my satisfy line test. I have a line test which signifies, wait, let me just illustrate to you using an example. Okay, let me just illustrate using example. If I have a polygon like of this shape, something like this, let me draw a polygon like this, which is basically, I have how many sides? 1, 2, 3, 4, 5. So I have a 5-sided, so means it is a pentagon. Basically it is a regular, not regular, it is a general pentagon. So if in somehow if I connect two of my vertices of a given figure, and I just connect the two vertices to get an imaginary line, this is my imaginary line. Okay, and if the line comes outside of my required polygon, see, my polygon region is this shaded region, which I'm just highlighting the region. This is my inside of my polygon, which is my M-like polygon, M-shaped polygon, you may think. So if the imaginary line is lying outside of my polygon, it would be treated as concave polygon. So I would be classifying my given pentagon to be concave. Okay, concave for any of the two vertices. If any one such imaginary line exists in the polygon, then I would be having my concave polygon. Convex would be what? Convex would be just the opposite of it. Convex would be just opposite of it. If I cannot draw an imaginary line which is lying outside of my polygon region from any of the two vertices, see, if I just connect any of my two vertices, let me just connect this with this. If I just connect my this with this, so I would be having, wait, let me just draw it here itself. If I just connect these two lines, so my edge is lying inside the polygon, so I won't be treating it to satisfy my line test. Okay, so let us now take another two edges. Similarly, if I take these two edges, are you getting it? Are you getting the idea what I'm trying to illustrating to you? Are you getting it? Yeah. If you connect any of the two vertices, and if any set of vertices, by joining that vertices you get an edge which is lying outside of the region of polygon, you should be treated it as concave, except if none of the two vertices yielding a line segment which would give you an imaginary line lying outside, if none of the set of two such vertices is present in my polygon, then the polygon must be convex. Are you get it? Are you okay with that? Yeah. So I think it would be okay with you, and you are also fine with that. So if I just draw here, again my line lies inside, so I cannot take to satisfy my line angle test. So let us further treat this vertex with this tree. If I join these two, I would get a line which is overlapping with my side of a polygon. See, which is not lying outside of the region of my polygon. It should be lying somewhere outside of my polygon region. So since it is not lying in my outside region, so I won't be considering the given vertices for satisfying my line angle test. So I have tried all my tests. You can also try these. For these you won't get the satisfactory result. So here you would be considering the polygon to be what? Convex. So this is just the basic generalization of convex and concave polygon. Okay, let me give you some of the figures you classify concave or convex. Okay, let me just give you few of my examples. If I have a polygon like this, okay, treat every line to be straight. I am just drawing roughly, so it might not look straight, but you should treat it straight. And another being a polygon like, suppose if I have this, and this, and this. So there are 4 shapes. Determine which of these are concave and convex. This one being, can you just say which type of polygon it is, convex or concave? What should I write, vex or cave? Can you just guess? Yeah, there is a set of edge. Why concave? Can you just tell me why? For what reason you have treated this as concave? Yeah, because since if I join these two vertices, I would get an edge, imaginary edge, which is lying outside of my polygon. So yes, I would be treating it as concave. Similarly, for this polygon, what is your opinion? It is convex or concave? Do I have any of my edges or vertices joining which would yield me an edge lying outside of my polygon? Is there such edge? No, there is not such an edge. So it would be what? Convex. Seems clear? Or any issues? Any issues here? Convex or concave? Convex. Okay. What about here? Do I have any edges joining which? Any vertices, 2 vertices joining which an edge would be yielding outside polygon? No, here it's also not. Yeah, very great, going good. So it is a convex also. What about the scenario here? If I join these 2 edges, these 2 vertices, would I get an edge which is lying outside? No, the edge is lying inside. So is there any vertices? Is there any couple of vertices joining which I would get an imaginary line outside? Yes, there are. Can you just spot? If I just join these 2 edges, these 2 vertices, I would get an imaginary line which is lying outside of my region. Okay, so this is my complete region, inside region, and the imaginary line is lying outside of my region, so it would be what? Concave. Seems clear? Okay, so let us now move our discussion. I have a regular. Let us discuss what are regular polygons and what are not. See, regular means all sides and angles must be equal. Okay, this is the basic definition of regular. See, suppose if I have a triangle, in triangle I would take, if an equilateral triangle with all the angles measure 60 and all the sides are of equal length, I would be naming it as regular triangle or regular 3-sided polygon. Okay, seems clear? Clear till now? So basic definition of regular is signifies all side and angle must be equal. Similarly, if I give you an hexagon, all of the angles must be equal for naming it as a regular hexagon. All angles must be equal with all sides are of equal measure. Okay, so it is my regular hexagon. Okay, so let us now move next discussion. Are you okay with until this regular as well as convex, concave? If you have any issues, you may just pinpoint at any of the time or inside polygon. Are you just clear? Okay, so let us now move. Let us move our discussion. Let us move to our exam. There is a famous property, very important one though. There is an important property about polynomials, naming sum of all the external angles are yielding 360 degree. It is basically a statement. Sum of all my exterior angles of a polygon is 360. Let me just quickly illustrate using an example. Okay, if I have a polygon like, let me just draw it straight. I feel agitated when I'm Oh, wait, this being this and this. Okay, a perfect triangle. So if I just see, how would I get exterior angles? That's main question first. How would I get exterior angles? How would I get exterior angles? If I have just drawn these interior angles, these are my interior angles. How would I get exterior? I would get exterior through extending each of my edges. Let us suppose if I have vertices like A, B and C. I have vertices A and B and C. If I just extend AB little bit and BC little bit, if I extend BC, I would get like this. I will just extend AB, I would be having like this. If I just extend AC, I would be having like this. So the angles which are lying like this outside, these are outside angles which treated as what? My exterior angles. So if this measure x degree, if this measure 125 degree, and if this measure 125 degree, what would be value of my x? You have to determine the value of x. So this is my basic illustration. Can you just go ahead with me? You just tell me with me, okay? So our property states, if you have any issues, or you may just try with yourself if you are comfortable, or I can just easily let you understand. Okay, so you may go ahead if you can solve. I've just given you the statement. You can just solve using that given statement, or I will pinpoint, or you may just check what I'm been writing here. So you may just try it first at your own. Okay, so you may just try and just try. Exterior angle A 125, exterior of angle B would be again my 125, exterior of angle C is my x. Okay, I have said that sum of my exterior angles, if I just sum it all, if I just sum of exterior angles would give me what? Would give me 360 degrees, and the sum is all of the summation of this, so it would give me 125 plus 125 plus my x times equal to what? 360 degree. So from this equation I would get the value of my x. If I just sum up these, I would get 250 degrees plus x degree equal to 360 degree. So for getting x, just subtract the equation by 250. I would be getting x equal to 360 minus 250. So I would be having, if I just solve, I would be having 110 degree measured. So I would be getting the value of my x like this, 110 measured. Similarly, let us now discuss another one. I am giving you to solve another question. Okay, are you clear with it? Okay, so let us move. I am just giving you another question which you may be solving and checking your answer. Let me draw a quadrilateral, extended quadrilateral basically. If I draw extended quadrilateral like this, okay, please don't mind if the side don't look straight. You may treat it as straight. If this is my 90 degrees, and if this is my 50 degrees, and if this is my 110 degrees, and it is my x, it is basically x. So determine x. You may just go ahead using the same property I have discussed. Go ahead and check it from here. I'm solving here at the blackboard. You should check. You should first try with yourself and then check here. Yeah, what you're getting? 110? Yeah, that's the correct one. I'm also getting the same. So this is how we utilize the property for finding an unknown value. Okay, seems clear? So let us now play with an activity. There is an activity, okay, which you would be solving with me itself. So I am given with the extended hexagon like this. I'm given with the extended hexagon like this here. Okay, seems like a crazy spinner. Yeah, so if I have an angles like I have also given an interior angles. This is being my A. It is given that it is my regular hexagon. So regular means what? All sides must be equal. All sides must be equal. Okay. Since all sides are equal, as well as all my angles are also equal, let me mark each angle be A. Okay, since all angles are equal, so here it's my A always. So and they are it is also given to us. It is also, let me use this. It is also given that the exterior ones, which would be like, if this is a P, exterior angles are also given, this being P, this being Q. See, these are lying making with the exterior extended edge, so I would be naming it as exterior angle. Any issues? Okay, no issues. Okay, so let us discuss. I would be having here Y, okay, and I would be having here Z. So I have X, Y and Z, and P, Q, R being an exterior angles. See, exterior angles would be how much? 6 exterior angles for a 6-sided hexagon. It's very obvious. Okay, when we had a triangle, it would be, when we have a quadrilateral, we would be having over 4 exterior angles, and if we would have a triangle, we had 3 exterior angles. So in case of 6-sided regular polygon, I would also have 6 exterior angles. So I have to say that the first question begins with, what's the summation of the measures of exterior angles? All the exterior angles, basically they are asking, first question is asking about P plus Q plus R plus X plus Y plus Z. Can you just pop up the answer? Use the direct principal rule for the exterior summation of exterior property. Yeah, it is basically asking for summation. So can you just pop up with the answer? Yeah, it is basically 360 using the same property. You would be right. You would be defining here summation of exterior angle property. Okay. Yeah. So the next question is of this activity. It is asking. Question is saying, is X equal to Y equal to Z equal to P equal to Q equal to R? Is this true? And if it is, then why? Okay, first solve the first part of the problem. But just check it is or isn't. Yes or no. Can you just guess which is the yes or no? Can you just guess yes or no? It is saying all the exterior angles are of equal measures. Are they? Can you see how they would be of equal measures? See, since I am given with the equal side and all the interior angles are also equal in my regular, and it is also given that my hexagon is regular, so obviously my exterior angles would always be what? Would also be equal in measures. Yes. Or you can just determine if you have understood the concept of linear pair. If you have a line, if you have studied the concept of linear pair, I would be having, if I have a straight line, a straight line like this. So if I have an X here, if I have a Y angle here, so using the property of linear pair, LP, let me write it as LP, using linear pair, I can say X plus Y would always be my 180 degree measures. Since in your protractor, which you would be using in your classes, here you would be having 0 degrees, 10 degrees, 20 extending up to at 90 degree, you would be having right angle 90 degree, and further extending up to, you would be having 180 degree. So it's basically saying from 0 to 180 you would get a straight line. Okay, seems clear? So if you are having the straight line, the sum of all the angles lying on that straight line would give me summation of 180 degree. So here also you can see for each extended edge, I can say that one of the angle is making A and exterior of angle A, okay, it would be my 180 degree, from which you can say here, okay, exterior of my A. Let me mark it as A, B, C, D, E and F, okay. So exterior of my A is which angle? Z angle, okay. Similarly we can write for all these. A plus exterior of angle B would be my 180 degrees, same all the ways up to, say, it will go to exterior of angle F till F, it was also 180 degree. Clear enough? So since all I can rewrite summation of all my exterior angles will be what? 180 degree minus of A angle, since it is equal for AR in common. So I would go just here and subtract these A's. Okay, so I would get my summation of all these angles. So every angle would measure this. So if 180 is my constant and A is also my same, so I would be getting same result for every of my external angles. So due to this, we can also prove using linear pair property. I can also say that yes, all the exterior angles are of equal measures. You have answered your y part. Seems clear? Have you had any issues in this concept of linear pair or in the calculation part? Feel free to ask. You can ask if you have any of the issues. Is it okay? Okay, right? Yeah. So let us now move with our last part of the question. Basically, yeah, so the last part of the question is asking for measure of an exterior angle. You have to determine what's the exterior angle in mathematical quantity if my interior angle, which was A, seems to be 60 degrees. Wait, it's not 60, it is given to be me. It's given if it is a 120 degree. If every angle measures 120 degree, what would be value of my exterior angle? If we have deduced our formula from here, which would be minus 180 degree with 120, you would be getting your each measure 60 degrees. So 60 degrees is your answer. Are you okay with that? Yeah. So okay. So further, before moving ahead, let me give you let me assign you a question which will be solving in front of me. Okay. You have to find the number of sides of a regular polygon whose each exterior angle has each exterior angle measures 45 degrees, and you have to determine how much sides the regular polygon would have. Determine sides, whether it would be 5-sided, 6-sided or 8-sided, etc. You determine using the property 45 degree. Go ahead, I would be solving if you won't be able to. How much you are getting? 8-sided polygon. Yeah, it's correct one. It is correct. How would you do that? See, you would be finding that total sum of all the external angles, total external angles would be my 360 degree always. And since every angle measures 45, so I would be having, since I know how much angles would be it would be my only, if I considered my determined side to be x, I would be having x times 45 measures. Since each measure is 45, it would be yielding 360 degree. So from here I would be determining the value of x, which is my 360 divided by 45, which further on simplification would give me 8. So it is a regular octagon, okay. So you would be drawing it like an 8-sided polygon, like this. These are 5, 6, 7 and 8. It would be like this, big brother of hexagon, this octagon, okay. Seems clear? Yeah, it is a regular octagon, so all the sides would be equal and all the angle measure would be equal. So okay, so I think you are pretty much clear with the concept of this property, which is summation of all my exterior angles. Let us now move towards our quadrilaterals, specific quadrilaterals, which are my 4-sided polygons. Okay, these are my 4-sided polygons, and you have to just take a look what are different types of quadrilaterals available to us for our scope of discussion. So here are basically 5 types of polygons. There are basically 5 types of polygons which we would be encountering in our discussion. 5 types of quadrilaterals. 5 types of quadrilaterals. Okay, which we will be discussing here. What are they? Oh, let me just erase. What are they? Number one being what? A parallelogram. It is very much important for our discussion. It shapes like this. Okay, it's lying inside only. So the property of polygons, let me illustrate one by one. Opposite sides are equal and parallel. Okay, opposite sides are equal and parallel. So which means if I just label A, B, C and D, I would be having AB equal to CD as well as AB parallel to CD. Okay, and the side would be my BC would be equal to AD as well as BC would be parallel to AD. So this is my most important property of a parallelogram, which you have to remember at any cost for solving any of my parallelogram question. Are you okay with that?
Yes.
Shall I move ahead with another set of property?
Yes.
Okay. So let us discuss another property. Another property states that opposite angles are equal. Okay. Opposite angles are equal. You would have to remember these properties, which are not complicated in scenario. You would be guessing a pattern which are similar with the 5 types of quadrilateral. Remembering 1 or 2 of the properties, you would be figuring out for rest of the 5. So don't take pressure on yourself. These are just the play of property, and you would be mastering every questions would be coming across to you. Okay, so don't feel panic. You would be mastering any of the questions, which I would be also discussing few of them after a while. So opposite angles are equal means if I have angle A like X, I would be always have angle C to be what? Y, not Y. It would be X only, since these are opposite angles lying opposite to each other. Similarly for B, if I have B is my Y measures, angle B is my Y measure, so I would definitely have, with no reasons other than that, a parallelogram where angle D would yield me a Y only. So okay, so opposite angles are equal. Another set of property, another property is my diagonals bisect one another. Diagonals bisect one another. Diagonal bisect one another. So it means if I just draw diagonals are basically joining opposite two vertices Diagonal seems curvy. If this is my diagonal AC and BD, they would bisect one another. Bisect means they would divide diagonal into two equal parts. This would be this part. If the intersection point is O, I can write AO equal to OC, okay, and my BO would be equal to what? OD. Seems clear? So this is mean diagonal bisect one another would mean. So these are just my three of the properties I've just stated. Nothing else than the fourth property. If any of the quadrilaterals satisfy these three properties simultaneously, I would be marking that quadrilateral as a parallelogram itself. Okay, shall we move ahead? Are you okay with the properties? I would also provide that given notes. Don't worry, don't just write all them up. You just try to listen. I would provide all the notes requiring for your understanding. You just completely focus on our discussion currently now. Okay, you just try to remember these properties. Let us move ahead in our next type of quadrilateral. Next type of quadrilateral is my what? Rhombus. It's my rhombus. So my rhombus figures like something like this and this. Something like, wait, it is a brother of square itself, wherein, let me quickly state the properties. Property means all sides are equal. Okay, all sides equal. If I just label A, B, C and D, I would be having A equal to B, B equal to C, C equal to D, D equal to AD. It means all the angles are of equal measures. Likewise in square, you would also find. There is a slight difference between rhombus and square. I would be letting you know in a while. Just focus on the next property, which I would be labeling is my C. All the angles, okay, all sides are equal, and as well opposite sides are parallel. Okay, opposite side parallel means here AB would be parallel with CD and my BC would be parallel in with the AD. So this is my second most property. Third property would be diagonals are perpendicular to each other. Diagonals are perpendicular to each other. Okay, which means if I just draw a diagonal AC and BD perpendicular to each other, means AC would perpendicular to BD and BD would perpendicular to AC. This is my basic property. Diagonals are perpendicular to each other. Okay, as well as the diagonals would also bisect as well as bisect each other. Okay, likewise in parallelogram, bisect each other. So which means if I have O, I would be writing my what? OA equal to OC. Can you come up with the next? Yeah, can you come up? OD equal to BO. Yeah, that's right. This is basically a bisection property. So other than these three, I have no other property. So if any of the quadrilaterals satisfy these three properties simultaneously, remember the word simultaneously, I would be naming that quadrilateral to be rhombus only then. Okay. So if you are comfortable with these two types of quadrilaterals, all the things have been done. Yeah, all the things have been done. Literally. Let me come up with the next set of quadrilateral, which is my third and fourth are silly enough, which we have already come up with, which are what? Rectangle, which you are been playing with since childhood. See, rectangle is my what? I don't have to show even properties. Opposite sides are equal and parallel. Okay, opposite sides equal as well as parallel. Okay, and if I just label A, B, C and D opposite, since opposite sides are parallel, as well as there is another property, opposite sides equal and parallel. Okay, there is another property that each of the angles, each of them angles with an adjoining edges are of right angles. Okay, all angles 90 degree. Another property, last one, being diagonals are equal. Diagonals are equal, bisect each other, bisect as well as perpendicular to each other. Okay, are you able to digest? Yeah, so if a quadrilateral satisfies these three properties, a quadrilateral is rectangle. Here is the main key is to be noted is all the angles must be 90 degree, and opposite sides, since opposite sides must be equal, not all the sides. If all the sides would be equal, it would come under the category of my next quadrilateral, which is my square. Okay, square has all the properties of my rectangles. Just I would be, if I just combine these two of my properties, I would, so I would have the same property, just my opposite word would be deleted. It would be like all sides. Okay, all sides are equal and parallel. All these properties are also here only. Okay, so yeah, just don't mind. Okay, so square, it's square, and another set of polygon, which is our kite, a special one. It is my kite. Okay, this kite, basically kite-like figure, as you've already understood, wherein if I just label A, B, C and D, it's special. They are not opposite, as we have just already see opposite side and opposite side are equal and parallel. Here the concept of opposite vanishes. Here the concept of adjacent or consecutive occurs. Means the side adjacent to that side, side adjacent to that side, edge adjacent to the side. So if this scenario would occur, you would be naming that quadrilateral to be what? Kite. Here my AD would equal to AB, and BC would equal to what? CD. So I hope so. Until now it's been clear to you, and we would be discussing our next sets of problems about these 5 types of quadrilaterals as we just discussed in the next section. Until which I hope so you have liked the session, and goodbye. Okay, so let's just meet in the next lecture.